Assalamualaikum and good day. You are with me again, Miss Huda. Let's do example number 4 for center of gravity topic. Find the location of the center of gravity from point C and reaction at support A and B. The information given are the wall thickness 120 mm, the weight or the unit weight of the brick wall 12.3 kilonewton per meter cube, and the weight of the beam, which is this is the UDL 3 kilonewton per meter. Let's find the center of gravity of the wall first. Here I have the wall that I divided into 4 sections. The first one is the triangle, section number 1. Section number 2, this is the rectangular section. Section number 3, another big rectangular section. And last but not least, the hollow section, and it is a rectangular shape. And we also have the reference point, point C, and I draw the y-axis and x-axis that intersect at point C. So any distance that we're going to calculate for the centroid is going to be to the axis. As usual, we're going to do the table to calculate for the centroid. The first shape that we have here is triangle. We need to find the area. It is 1/2 times B and times H. The B for this triangle is 1 meter, and times the H, it is 1 meter. For the X bar, is going to be from the centroid of the triangle to the x-axis. So, kita perlukan berapa panjang ini. So, the first one yang kita nak kira is berapa panjang dari centroid to the bottom of the triangle. It is 1/3 times with the H of the triangle 1 meter. And to get to the x-axis, you need to add another 2 meter to the distance. That is for the X bar. Next, we need to find the Y bar. The distance going to be from the centroid of the triangle to y-axis. Let's draw the line from the centroid to the end of the triangle. It should be 2/3 times with the breadth of the triangle 1 meter. And we have to add another distance here, which is 2 meter plus 1 meter plus 1 meter and plus another 1 meter to get to the y-axis, 5 meter. So add another 5 meter here. The calculation is as shown here. Then we can get the value of AX bar by multiplying the value of the area with the X bar, and for the AY bar by multiplying the value of area with the Y bar. The second section is the rectangle. The area for the rectangle will be B times H. It is 3 meter times with 2 meter. For the X bar, it should be half of the rectangle to get to the x-axis. So the value going to be 2 meter divided with 2. And for the y bar, it's going to be from the centroid of the rectangle to the y-axis. Here you have half of the B, and you have to add another 3 meter to get to the y-axis. Therefore, 1/2 times 3 meter plus with 3 meter. You can refer to the table here. The calculation is similar. Repeat the process for AX bar and AY bar. For section number 3, the area would be P times H for the rectangle, 3 meter times width, the height of the rectangle, 4 meter. We need to find the X bar from the centroid of the rectangle to the x-axis. It should be half of the height of the rectangle, which is 4 meter divided with 2. And to get the y bar, the centroid of the rectangle to the y-axis, it should be half of the breadth of the rectangle, which is 3 meter divided with 2 to get to the y-axis. And refer to this table. The calculation is here. AX bar and AY bar, you can get the value by repeating the same process as the previous section. For the next section, we have the hollow rectangular section here. Get the area, which is 1 meter, the B times with the H, which is 2 meter. To get the X bar, is going to be from the centroid of the rectangle to the x-axis. It should be half of the height of the rectangle, 2 meter divided with 2. And you have to plus another 1 meter here. To get to the x-axis. And for the y bar, the distance going to be half of the breadth of the rectangle, which is B divided with 2. And plus dengan another distance here, 1 meter to get to the y-axis. 1 meter divided with 2 plus 1 meter. You can calculate and get the same value as what I did here. Repeat the process for AX bar and AY bar like the previous section. And we can get the total area, total AX bar and total AY bar below here. But you have to remember there is a section that you have to minus from the calculation, which is the fourth section here, sebab this is the hollow section. So kita kena tolakkan because of the area itu tidak masuk. So for the section number 4, tolaklah daripada value total. Total area, total AX bar and total AY bar. Finally, we can calculate the centroid of the whole wall. Calculate the X bar using the formula of total area X bar divide with total area. So total area X bar, get the value from the table and divide with the total area of the wall, 16.5. Repeat the same process for Y bar using the formula of total area Y bar divide with total area. According to the table, total area Y bar is 44.834 and divide with total area of the wall. For X bar, you will get 1.646 meter from the x-axis, and for the Y bar, it's going to be 2.717 meter from the y-axis. Next, we need to calculate the volume of the wall since kita nak kira berapa reaction at the support of A and B. For volume, the area of the wall times with the thickness of the wall. Thickness, the area yang ikut kita kira dari table, and the thickness of the wall given in the question. 120 mm, convert into meter, it becomes 0.12 meter. You will get the total volume of the wall is 1.98 meter cube. To get the weight of the wall, sebab kita perlukan untuk kira reaction, the volume of the wall darab dengan the unit weight of the wall. Because dalam soalan, dia bagi terus unit weight. 1 meter cube berapa berat wall. Sebab volume kita 1.98, so we have to times with the unit weight and get the total weight of the wall. We can draw or mark our figure here with the value of the weight of the wall, 24.354, and the distance of the centroid to the y-axis, 2.717 meter. The distance of centroid to the x-axis, 2.646 ni you tak letak pun tak apa. Sebab dalam our calculation to get the reaction, kita takkan pakai value ini ya. But because of this question ask you to find the centroid, that's why you masih kena kira. But this is the value yang you perlukan untuk dapatkan the reaction. And jangan lupa juga dalam soalan pun the load of the beam pun diberi, which is 3 kN per meter. So you boleh kira moment and take it dekat mana-mana point of reaction. Kalau you nak ambil dekat A atau dekat B. And in my case here, calculation saya take dekat B. Firstly, we have one reaction at A, which is RA pergi ke B. So this is clockwise, positive, times with distance dia adalah 1 meter plus 2 meter plus 1 meter plus 1 meter and another 1 meter equal to 6 meter. Next, we have the load from the beam, which is 3 kN for every meter. This is counterclockwise, meaning dia akan jadi negative, and we have to times with the length of the beam. Tapi kita kena tengok yang mana yang arah lawan jam sahaja. Yang arah lawan jam is exactly sampai point B ni saja ya. So total dia adalah 7 meter. Distance from the centroid of that 7 meter long beam. So half of that 7 meter dari centroid nak ke point B, it should be 3.5 meter. That is for the beam yang arah lawan jam. Yang arah jam pun kita kena kira. Ini nak ke point B. We have 1 meter long beam, and dia adalah clockwise, so plus 3 kilonewton per meter times 1 meter, and you have to times the distance from the centroid to point B, which is 1 meter long beam bahagi 2, you dapat 0.5 meter. Dan last kali, kita ada loading that come from the wall, which is pergi ke point B. The load is 24.354 kilonewton. Dia adalah counter clockwise, so minus. And times the distance to the point B, 2.717 meter. Equilibrium, therefore, equal to 0. So this is the calculation, ya. Ini adalah daripada beam yang arah lawan jam. This is the wall. And ini adalah beam yang arah jam, ya. So sama sahaja macam yang saya dah tulis dekat depan. And we can simplify the calculation and get the value of RA 23.028 kilonewton. Next, we can find the RB using the force equation. So daripada kiri kita kira supaya kita tak tertinggal sebarang reaction ataupun forces ataupun loading daripada figure ini. So we have RA going up. Next, we have 3 kilonewton per meter. This is the beam. So beam adalah loading, so turun ke bawah for the total of 8 meter long. And we also have the load that come from the wall, which is 24.354 ke bawah, so tolak. And we also have the reaction at B, which is plus RB, equal to 0. So inilah dia yang saya dah buat. Then we can replace the value of RA that kita kira dalam moment equation here, and finally get the value of RB. So that's all for example number 4. I'll see you again in the next video. Thank you so much and have a nice day.